Hi guys, Miss Bailey again. Oh, excuse the crazy workout hair. I apologize for what happened in the last video, but hey, maybe this is encouraging me to make videos shorter so you guys don't have to listen to me ramble as long. This video is going to be focused on working out math. So if you watch the other video, you're good on all the definition stuff. Here's how the math you're going to see in this class. So a very common problem you might see involves just two vectors acting in two different directions. And so you could have two vectors acting in opposite directions, which you will learn how to handle. You add or subtract. But I could add in two dimensions. So let's say I have something being pushed forward with 8 newtons of force and being pushed to the right with 2 newtons of force. You guys haven't really seen newtons very often yet, but they are just the way we measure force in this class, and you will see them eventually, so I'm just getting you comfortable with units other than just meters or inches on the sides of triangles. So if something is being pushed forward at the same time it's being pushed to the right, what is actually happening to the object? It's going to experience some combination of these two motions. So I can combine them by drawing a triangle. You will learn how to do all of that probably in a separate video. But for now, I want to know what this side is. So something the other video forgot to mention is this is where Pythagorean theorem would come in handy. And I would pick the Pythagorean theorem equation anytime I know two sides of the triangle and I want to find out a third. So for those of you who need a refresher on Pythagorean theorem, I can give you one. C is always the hypotenuse. And then A and B are these other two sides. It really doesn't matter which is which because you end up adding together their squareds whenever you are done. So now I'm just going to plug in stuff and solve. So I'm going to get my calculator out really quickly. 8 squared plus 2 squared equals c squared. So I have 64 squared plus 4 squared. Oh, be careful. Easy to make an algebra mistake like that. Plus 4 equals c squared. Square root that's 68. And I get about 8.2425 if you round newtons. And just an FYI, we're going to stop paying attention to sig figs because if you notice, if I had round this answer to proper sig figs, I would get 8 newtons, which is kind of telling me that both of these sides are the same length, and that's just not true. So don't focus on sig figs. We will come up with a rounding rule for you, and we'll try to make it pretty clear in directions and stuff for what you need to round to. A safe bet is 2 decimal places, but read the directions over anything else. Great. Let's say these weren't forward and to the right. These directions were north and east. My final combined direction would be northeast. So you still need to just remember direction is going to be a big deal because we are dealing with vectors and arrows and things. You will very rarely be asked to find theta, but usually not on a test or a quiz. So I'll put that at the very end of the video so you don't have to watch it. If you're just curious, you can skip to that part of the video. You can watch it. Otherwise, you can just cut it off when I start talking about it. Great. The other thing you will see, and this is something you're going to see a lot in this class for this unit, you are going to see a triangle that has an arrow at an angle. What I mean by at an angle is there's an angle right here. You are going to quote unquote break that into its two sides that we call x or y. Sometimes we'll call them velocity x or velocity y. We could also call them force x and force y. The big thing here is that these symbols are in either the x direction or the y direction, which maybe you can think of by using the coordinate plane from math class. So that's what those labels are always going to be called. And we will usually know one side of the triangle and an angle. Okay, so maybe I know this side is 10 meters per second, and let's say I know the angle is 37. Okay, my job is to find the other two sides of this triangle. So we are going to be looking for what we call the y component and the x component, or the y side or the x side. So how do I do that? My best friend that you learned in the last video, SOHCAHTOA. Now, which one would I pick for which one? Always do your problem solving strategy. Label what you know. I know theta, you could label that if it's not filled in for you. And what are you looking for? Well, I'm looking for both of these sides, so I'm going to go ahead and name them opposite and adjacent based on my angle here that I know. Okay, you could go ahead and solve for this angle if you wanted to. And you could use that angle and the other two sides, but I would always just use the angle they gave you, just in case. I doubt you would mess up something that easy as like adding, but just in case. And if you're curious about how I got this, this is 90, this is 37, so I added those together and subtract from 180, or just 90 minus 37 gets 53. Cool. So now, which equation do I use? Now that I have everything labeled, pick a side. I'm going to go ahead and pick opposite. I'm looking for my opposite side. I know my hypotenuse. So which trig function has both opposite and hypotenuse in it? That would be so. So I'm going to plug stuff in. I picked out my equation. Sine equals opposite over hypotenuse. I've decided to, well, the angle is 37, the angle we are using. And notice how I write this. This is how I would type it into a calculator. Sine equals, or sine of 37. And again, nothing goes in there except a decimal. Equals my opposite side we've labeled y over my hypotenuse, 10. Now from here, I just rearrange. When I want to get y by itself to figure out what this side is equal to. So I am going to multiply both of these sides by 10. It's not by itself over here because it's being divided by 10, so I'm going to multiply it. I'm going to do the exact opposite. I'm going to multiply by it for it to cancel out. But I have to do, what I do on one side, I have to do to the other to keep it the same, so I'm not actually changing anything. And when I plug this into my calculator, I should get about 6. And I'm going to label that meters per second, because this side of the triangle is meters per second. So this must be a velocity triangle, which means all of the other sides are velocities. I could have a force triangle. I could have a distance triangle. I could have triangles with made out of different things now, so that's just something to keep in mind. All right. Now the next side. I am looking for my adjacent side, and I know my hypotenuse. Yes, I know my opposite side, but I want to try to avoid using calculated numbers when I can. And the trig function that has both adjacent and hypotenuse in it is cosine. So I will go ahead and write out that formula and plug stuff in. Cosine of, we know the angle is 37. Equals that adjacent side over the hypotenuse. And again, we are trying to get that 10 away from that x, so the x is by itself. And I'm going to do the exact same thing I did in that first problem. And I wind up typing this into my calculator. Now, something to be careful of. I've seen some people do this before where they accidentally invert the number. These are not getting multiplied together. You are plugging something in to some calculator trig function, so it needs to have the correct angle there. Be careful. Do not plug those in backwards. That is an angle in there. And when you plug that in, you should get about 8 meters per second. And that will be those sides of the triangle. So be sure you know how to do both of these basic math functions. Pythagorean theorem, if I know 2 sides. If I only know 1 side, I'll usually be asked to find the other 2 sides, and I'll do so with trig. So now I have a couple of tricks for you. If you would like to pause the video or move on because you feel like you don't need the tricks, want the tricks, that's your call. So that triangle that we dealt with before is what's called a 3, 4, 5 triangle. There are triangles that exist from trig that maybe you remember some tricks with. They're called trig triangles. They are 90-degree, well, at least some of them are 90-degree triangles. One of them is called a 30, 60, 90 triangle. And that is because it has those corresponding angles. Well, the sides, if you wanted to find the sides, if you knew one side, you could find the others without using trig. That is understanding that certain triangles always have certain patterns. So whatever this side, opposite of 30 degrees is, which would be called A, the hypotenuse, whenever it's at 30 degrees only, or 60 degrees, it could be the other side of the triangle, but the small side is always going to be some number, and the hypotenuse is always going to be twice that number exactly. And then the other side will always be whatever your first side was, your 30 degrees side was, times the square root of 3. Another trig triangle was 45 degrees. You will see this one at least once in this class. But this is also what's called an isosceles triangle. Both of these sides are the same because they're opposite of similar angles. So both of these sides will be the same as each other, and this side I think is like one side times the square root of 2. So there are probably more. You can use them, you don't have to. I like to avoid trig where I can, so there are those tricks. The last one I want to warn you about is the one that was in our example just now. 37 degrees and 53 degrees are what's known as a 3, 4, 5 triangle. The sides of the triangle are multiples of 3, 4, and 5. Well, the 5 side is obvious. It's the longest side, so it's got to be the hypotenuse. 3 and 4 are a little trickier. 3 is the smaller side, so it's going to be opposite of the smaller angle. For that same reason, 4 will be across from 53. So some of these triangles and most of these triangles are not going to be drawn to scale, so you might not be able to obviously tell which one's the shorter or the longer side all of the time. Or they should be drastically different and they aren't. Just kind of pay attention to little tricks like that. I know if it's supposed to be a bigger small angle, it should have a smaller side across from it. If it's a small angle, a smaller side across from it. Okay. Whew. So for this example right here, I'm just going to redraw it down here. This side said it was 10. The problem gave us this side, and it was 10 meters per second. So the trick with this is a multiple of 10 is a multiple of 5. I multiply 5 times 2 to get 10. So these other 2 sides, I will also multiply by the same thing. And I get these numbers, which if you scroll back up, those were the answers I got when I plugged it into my calculator. I rounded a little bit, sure, but they were the same. So that's just a trick you can use sometimes. Only when you see these specific angles can you assume all of these little tricks and maybe get out of doing trig for a problem. All right, that's one of them. Here is the last little bit that you may see in a future class. I don't think you'll see it in my class very often, and even if you see it, it'll be optional for you to solve that problem. But I gave you a problem where maybe you would have to find an angle. So I don't know that we ever solved for, I think we did. It was like 8.6, 8.25. I think that sounds right. But let's say we're looking for that angle. How would you go about solving for it? Now I'm not using units here. but still identify what you're looking for and what you know for sure. I'm not going to use this number because I calculated it, so I'm going to avoid it if I can. So these sides, in this case, since we're comparing them to this angle down here, this side is opposite of that angle, and this is adjacent. So which trig function would I use since I know both my opposite and adjacent angles? I'm going to use that. And I'm going to have to use one of my SOHCAHTOA equations because theta is going to be involved. So I need an equation with theta in it. Ooh. So I'm going to write out my trig function. And I'm going to plug stuff in, just like normal. I don't know theta, so I'm going to leave that alone. And then opposite is 2, adjacent is 8. You could go ahead and simplify this if you want, but you don't have to. The hard part here is separating tangent from theta. I can't just like divide by tangent. It's a little weird. You kind of do a different version of divide by tangent to get rid of it. They're not getting multiplied here, so you have to do something different. And that is called the inverse tangent. So what happens is I can move the tangent to the other side, but I have to take the inverse of it, which is this teeny tiny -1 right here. Now, the inverse button for each of the functions is found directly above the original function. You just have to hit the second button and you can get the inverse option for that function. But it'll look just like this, and it'll look just like the other trig function in the way that when you type it in, it opens up a parentheses, and then you'll just plug in whatever's on the other side of that equation, just like that. And so when I do that right now, I get about 14.3, so I'll round that to 14.0 degrees. If you get something smaller, or if you get a negative, like if you get a really weird decimal, there's just something to look out for. So if you get a decimal degree, or a negative, those are both really weird degrees to have. They're very unusual. That usually means your calculator is not in degree mode. Your calculator needs to be in degree mode for it to happen, for you to get the good answer to happen, I guess is what I was trying to say there. If either of these things are happening, this usually means you're in radian mode. So you can change that pretty easily by hitting the mode button. It should be found on your calculator, maybe towards the top, and switch from radian mode to degree mode. This is what you want. Degree mode for this class, always. That may be different in other classes. Okay, great. Hopefully this was helpful. Rewind as often, replay as often as you need. Good luck.